Hello and welcome back to the second video in my commercial grade C++ video series. We're going to continue on today, or actually even really start today, building our commercial grade software. Yay, that's it. And what we're going to do today is we're going to start with a bit of infrastructure code. So what I want to do is I want to have the proper setup of the logging, and I want to prepare or maybe even finish the infrastructure for the separation of our logical parts of the software. Now, if you remember, we divided, at least from the dependencies point of view, we divided our software already in, let's call it three parts. We have the general part, which is just some general utility, and then we have the web server part and the machine interface part. And what I want to have is that each part, each proper part, not the general part, of course, because it's just the general infrastructure code. I want to have each part running in its own, let's call it service or microservice. It's not going to be a proper service, because a proper service is something that can run as a solo executable on like a Windows service. Like if you go to services, this is what a real service would look like. It would run here, or it would be able to run it on the Linux server manager. So this would be a proper service, but I want to divide my application in so-called like services. So what I would want to call these are like the microservices of the big applications, but I think we're going to call them services because I don't like the overused term microservice. Now, what I want to build today is I want to have a bit of infrastructure code that sets up SPD log in a way that we can create a logger per service. This is the main purpose behind it. I want to have a logger per service. So each service is going to have its own logger, and we are going to have a general logger that is going to be used for all of the basic infrastructure code. But let's dive into and start with that. So I'm going to go to my library. I'm going to delete the dummy because we do not need a dummy. And then I'm going to get started, and I'm going to add a new item. I'm going to call this one, maybe let's put this into the subfolder util. And let's call this one logger factory, because it's going to be a factory for loggers. Okay, so let's give it a namespace, ZGCPP. I think I want to capitalize that. ZGCPP looks a bit nicer. And yeah, what I want to do now is I want to create myself a logger factory. So actually, how I'm going to do this is I'm going to do that a bit different. We're just going to have a few methods. I'm going to go and call this one setup logging. So we're going to have a setup logging function, and then I'm going to have a logger retrieval function, which is going to need SPD log and memory. Include memory like this, and then I'm going to include SPD log. Oops, not that Microsoft header here. SPD log, SPD log.h. That's what I need. And then what I have here is I'm going to have a SPD log logger that I want to return, but it's not a straightforward logger. I want to have an std shared pointer, because this is how loggers work, and I want to call this or I want to call this function get logger. So yeah, I want to be able to get a logger, and I want to get a logger for a certain module. So let's have a string in here, a const std string, and I'm going to call this one module or logger name, so that I want to have a bit of a retrieval for that. I want to have some documentation attached to that, which is of course not set up. Where is it? It should be somewhere in like code editor or something. Text editor, I think it is. And then I want to go to CPP. And there should be somewhere where have they configured that? Is it in code style? Here, Doxygen. I want to have it is already at --/ --. Is it already working? Okay, yeah, I was just a bit stupid. I don't know why it didn't work the first time. Okay, pointless time waster. Okay, so configures So default logger, this is the first thing that we want to do, and then we're basically going to retrieve a logger for a given submodule, and then we just have a creates it on demand by cloning the default logger. So the default logger will be our root, and then we're going to recopy from that. And that's going to be super simple. Okay, logger pointer. That's basically what I want to do. I don't have Visual Assist yet installed on this machine, or not on this machine, on this Windows installed, so we need to be able to get around that. So first of all, I want to have my logger pointer, and then we're going to say spdlog default logger. And this gives me the logger pointer, and then what I can do is I can customize this logger. So first of all, I want to actually set the pattern. That's more or less the only thing that I want to do for now. I want to set up a new pattern of the logger, and I think, can I rename that one? Set name? No, I cannot set that name. Maybe we do just going to clone the logger into a new name. CGCPP, and call this one the default logger, and then we can do spdlog set default logger, which will basically just replace the logger with everything that we have cloned from here, which I think would be also quite a nice thing to do. Okay, so let's find out how to do this pattern. So pattern, there is the GitHub wiki for spdlog. And I think on custom formatting, the pattern should be described. I'm not really sure, but I think they had some documentation how the default pattern was looking like. I'm not sure, but I think they don't. I think I want to quickly steal something from myself, because I don't want to bother you now experimenting around until we get the right pattern. I do just want to steal that from my university project. Because I think, yeah, there it is. That's the pattern that I want. Yeah, it's it's just the way it is. Logger, std, color, empty, okay. Yeah, that's okay. I just want to steal the pattern, I think. I don't know what I have done there exactly, but I just want to steal the pattern. And then what I also want to do is I want to set the level of the logger. So what kind of messages the logger will emit. And I want to check if CGCPP release is defined. So that's kind of like the switch here. If release is defined, we do just going to set the level to spdlog level. Now, how was it? Level? Is it just here? Can we just do it like that? Yeah, it seems like we can do it. If we are on release, I only want to go to info. Or maybe debug, but I think info is enough, and otherwise we go to trace. That's like the default configuration for the logger that we want. So development should still stay here, and then release is the only thing that should switch to the info level. Okay, that's good. And now we basically have created and set up our default logger. Now I want to have the cloning of the logger. Now I'm not sure how I can do that, but there is like this logger registry. Get, I think it's a get function with a name. If the logger doesn't exist, it returns null pointer. Okay, that's good. So let's do it and say auto logger, and the logger is equal to the logger name. This is why I've not used the string view, because spdlog does not support string views in this case. And basically what I want to do is I want to retrieve the logger like that, and then return it. And if not logger, so if the logger was not registered, I do want to create a new one. So how do I create a new one? Basically, I just say logger equals spdlog default logger clone. And then it's the logger name. And I think it should automatically register that. I'm not sure if I need to register the logger. Yes, I need to register it, as it seems. So then let's also register the logger and then return it so that it can be retrieved afterwards. This just makes sure that we can call this getLogger function from wherever we are. We don't really need to like care if the logger exists or if it does not exist. During the single-threaded creation of our logging subsystem, or our services as well, we can just receive and create the loggers without any issues and always call the getLogger function, and we're always going to get a proper logger. Okay, this should be enough for the logger factory. We can just simply test that if this works. So what I want to do is I want to call this, go in here, go to util and the logger factory. And what I want to do is, let's maybe just keep this spd log info in here. And we're just going to call this one info before setup. And then we're going to have an info after setup. So the like general spd log logging. And then I say cg cpp setup logging to set up all the logging. And then I say auto aux logger, so the auxiliary logger. And then I will basically say get a logger. And in this case, I want to get the, maybe I want to have the, let's maybe make this a bit different and let's make the name automatically. Std string logger name equals cpp dot, I'm not sure, using std string literals. Of course using namespace string literals. I'm not sure how string literals are working again. String literals are really useful. It's just the s attribute. Okay, it's just s. So I'm just doing it like that to make this a string, and then I can just take the logger name and append these two strings together without any issues. And we can also make this like a const auto composite logger name. And then we just take the composite logger name wherever we are so that we have this prefix going. You can see that we have this logger prefix here. And then basically I can just sub index here, and then I can just call this one the aux logger. And then I can go to the aux logger and say info from aux. Okay, that's nice. And then what I can also do quickly is debug message. I'm only here on debug, and we can simply just now play a bit around and see how our logging to subsystem work, if this all goes together without any problems. And yeah, you can see we start with the normal info here. So info before setup, we do not have a lot of informations here. Now on the second one, the after setup, you can see that we have the thread ID and the name of the logger. So you can see that the setup worked correctly. Then we have the info from aux, which also has the proper logger name with the .aux. And then we have the debug for only debug messages. Let's quickly play this again in release and see if the message has disappeared. Now it's disappeared because basically we don't have it here anymore. I think I do want to have the logger name before the thread ID though. I don't know why I did it like that. So the logger name is here. No, that's the level. Then we have the logger name, then it's the thread ID like this. And I think this should make this look a bit nicer. Yeah, I think this is how I want it. Because I mean, yeah, but I think it's okay like this to have it. Oh yeah, I managed to break the console. Good. Yeah, okay, so let's maybe call this a day for logging. This is everything that we need set up for logging. That's good. Now what I want to do is I want to build the service infrastructure. So we're going to have a services folder that basically implements the concrete services later. And then what I want to do is I want to have the service, how do I want to call this? maybe we call the system. So this is the system folder, and inside of system, we're going to implement services. So system service manager. I don't know. Let's maybe keep this flat here and call this one, then let's call this one basic service.h. So we have a basic service. It's going to be the base class for all the services. G commercial grade CPP class basic service, and let's call these like base class for all services. So they will basically, or this class will basically make sure that all the thread is created and everything works in a proper way. I am just going to get myself a bit of a basic structure in here for that now. And then what we're going to have is we're going to have the service manager.h that is going to manage the services. So CG, CPP, and then we're going to have the class service manager, public, and this one is quite small, it's private. Okay, so we do it like that, and we call this one manages services. Okay. Now we're going to have a protected function in here, get logger, to get the logger from the service itself. Or do we want to have it protected? I think we want to have it protected. We can later on expose it, I think. But let's just start now with this logging subsystem so that we integrate this in services. So util logger factory, we go like this. And inside of the logger factory, we have this function to retrieve the logger. So we have an std shared pointer of an spd logger, and we're going to call this one mlogger, so the logger for the service. So we want to have this exposed. I think I might wanna in the logger factory, let's say using logger equals std shared pointer spd logger, just to expose this a bit. Simple alias for loggers, and I think let's just keep this in the logger factory because that's how it normally works. And we can in the logger factory actually already make this one simpler by just calling this one logger. Then we can make this one cg_cpp logger like this, which makes it a bit easier to read. And then we can call this one also logger, and then we have the mlogger in here. Why do you not want to get green? Okay, because as it seems it is a bit stuck. Okay, so how I want to now write this function. I want to write this one logger, get logger. I'm going to create a copy in here. It's going to be const, and it just returns the mlogger. It's a simple function like this. No more need to that. We can even like explicitly inline this and returns a copy of logger. I think we can make this. I'm not sure. Can we make this a const? Can we log on a const reference? I'm not sure. Let's quickly try this out. If I can go to system basic service basic cg_cpp basic service svc. Of course I don't have now access to that one. Let's make my class my svc, which is a public cg_cpp basic service. We can keep this infrastructure code in here quickly. Let's make this one a public and void say hello to just quickly call the get logger function. And can I do info on that one? Can I log? I think I should be able to log something on a const logger, but I think it's just a pointer maybe. I don't know. Let's create this service here and say hello quickly and just see how this works. If this has any issues, but I think it should just interesting. Access violation. Seems like a null pointer. Yeah, of course it's a null. Of course it is, because the logger is not initialized. Because we don't have a constructor yet. Of course. We need to have a constructor for that, and I want to have a const std string reference name. Or actually we can make this one, let's make this one a string view. String view name, so we have the name of the service that is being created. Let's include a string and string view. I think it will probably be growing a bit bigger. Okay, so first of all I want to also now of course store the name. Let's add some documentation here. Logger pointer. We can make this one const and name of the service. Okay, like this. And then of course I need to initialize that one. Name. And then I can say logger equals create or get logger in this case, and I get the logger with the name in here. Interesting. What's the problem with that one? Too many arguments. Why are these too many arguments? Const std string reference. Inline const. Like this, because the get logger function is overwritten here. But that's okay. Yeah. Maybe this one should not be called get logger. Get create logger. Let's call this one like that. Get create logger. And then we can do it like this to create a logger, which will break the code here because the service constructor is not called properly. And we're calling this one basic service in here with the name let's call this one my svc here. And then we should be able to, this should be able to run. Okay, let's see, and we get the cgcpp my service hello d. So yeah, we basically said hello from the service. Now, of course, what we need to do is we need to write a lot more, like features of the service. We're going to have a void start, the void stop. This is going to be the interface of the service so that we can start it and stop it. Starts the service. Then we have here stops the service, simply like that. And then what I want to have is I want to have a function await, and this function waits the service termination. So basically this await function, it will return as soon as the service has terminated. And to make this one happen so that the whole class is a bit safe, I want to call stop await here so that in the destructor we definitely know that the service has been stopped, because we are working with threads, and if we don't stop them, it will be a bit of a madness. Now let's create the bodies for start, stop, and await. Now stop will be a quite simple one. I do think I want to work with atomic here. Here I'm not sure if we really would need them, but I would like to use them anyways. And we're going to have the run flag. We're going to have the stop flag. When set, the service shall terminate. And here we have the run flag while set is running. I think we could get away without atomics here, but yeah. Basically what I want to do is I want to just test and set. I think since we really need memory order. Maybe we do. Let's just keep them in here. Let's just keep them acquired here, and then at start we're going to implement start in a sec. Await is a simple one. While run flag test std memory order release. I'm not sure if we can do this. Maybe we just use bools. Because I only... No, I will use bools here now because we're only going to have one read and one write, and I don't really care about memory order, I think. We can just do this like that. While std this thread yield. This would require us to include thread like this. So we this thread yield here. Yeah, and that's basically it. Inside here, what I want to do is I want to set the run flag to true, and then I want to start it. So if not run flag, I set the run flag to do, and I do something. Now I need boost threads, and I don't know how to do it, so we need to check the docs. Okay, so I've opened up the documentation for boost threads. They seem to be kind of compatible with the normal standard threads, but yeah. I still think that we're going to use boost threads. They have a few more things that yeah, allow them to do something. Yeah, we're just going to, I think, play a bit around. No, I don't want to zoom in like that. Sorry. Just had the button locked, I think. So let's hashtag include boost thread.hpp. That's what we want, to include everything that's related to threads. And I think we can have a boost thread here. Work thread. So this is a thread that performs the work. So actual thread that executes the work. Okay, so work thread. We go in here, and I'm not sure. Do you have a problem with the run flags are not initialized? That's a problem. False. Okay. But I think the thread should be no problem. So work thread equals a boost thread. I think they have a lot of attributes that you can push in. You can also push in thread attributes, and it's quite interesting how they thread data pointer. They have quite a lot of things in here, but yeah, I just want to quickly start the thread like this and provide a function in there. So we're going to have a private function in here, private, and we're going to call this one void thread main. Simply like this. And this one runs the async code. Okay, something like this. And then in the thread name, we just, come on, Visual Studio. Well, can it be that hard to create a private function void thread main? It seems like that. I love that Microsoft puts a cancel button everywhere that you cannot press. Oh, come on. Ah, yeah, okay, it did not cancel, that's okay. Now we have the thread main here. Run flag will be false as soon as the thread terminates. That's basically how it works. We set it true, we started, and the last thing that the thread does is it's setting it to false. We could have a problem with non-atomics here with instruction reordering, so maybe we should use, at least for the run flag, the atomics. Atomic flag, run flag clear, std memory order release. I think simply like this, run flag test with the default memory order in here to just test it and yield, because we don't care really on a wait. Test. So if it's not, we can actually test and set here. Test and set. Std memory order acquire. So we test and set it here. And if it was not set previously, we go in that code. Then we reference the basic service thread main. And we're just giving this attribute. This, I think, should do the trick. I can quickly get the logger and say, yeah, get the logger info worker thread or service thread started. That's maybe a good log message here. Service thread stopped. And then something in between here. And then into here we have a while stop flag. While not the stop flag is, we want to do something. And in this case, I say this thread yield. Or we can say sleep for using city chrono literals. Chrono, namespace literals, and then let's say 100 milliseconds to not put so many load on the CPU. And yeah, this should be our code for now. So we can start here, and then we can say, and we'll quickly do it like this. This should hopefully work like this, because the destructor should do the trick. Yeah, service thread started, service thread stopped. Of course, the logging has not been initialized. It's not cool. Setup. How did I call this? Logging. How did I call this? CPP setup logging like this to set up the logging. And then we maybe say in SVC, say hello. No, because it does not really do it. We don't really need to say hello anymore. It's not a good idea, but I want to have as a SPD log info, say app starting, or app started, and just so that you can see that the threads ID are matching. So you can see 5000 is the thread ID here with some numbers, app started, and then we have the different thread ID, service thread star stated. Yeah, okay, that's a typo, started and stopped. So you can see that the threads work, that the service threads work. And I think that's it for today. We have the basic infrastructure here for the threading. The only thing that we now need to do is we now need to like incorporate the superclass a bit more. Currently it's just doing nothing, which is not good. Of course, we need to have a few callbacks in here, make it a bit more safe. And yeah, that's basically what I want to do in the next video, so that we incorporate this a bit more. So thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.